Assalamualaikum students, hope you are doing good. This is lecture for grade 8 physics. The date is 30 November 2020. We are going to start unit 5, which is gravitation. In unit 5 gravitation, the learning outcomes for students are: the student will be able to state Newton's law of gravitation. The student will be able to state about gravitational forces are consistent with Newton's third law of motion. The force of gravitation. Newton's conclude that there exists a force due to which every body of the universe attracts every other body. He named this force as force of gravitation. So, gravitation means that force by which Earth attracts every object toward itself. So now we will study how we get the concept of force of gravitation. As Isaac Newton was the first scientist who introduced about the force of gravitation. In 1665, Newton tried to solve the mystery that why Earth is revolving around the Sun, and similarly, why the Moon is revolving around the Earth. The suddenly apple falls from the tree, and he focused that why this apple comes toward downward, and then he concluded after so much research that there is a force on Earth that attracts every object toward itself, and that force is force of gravitation. Then through this concept, he also solved the mystery that if Earth is revolving around the Sun in a particular orbit because of there is a force that is the force of gravity, and same for the Moon that is revolving around the Earth has the force of gravitation. So all the objects that are revolving in their specific orbit and all the objects that attracts toward the Earth are due to the force of gravitation. So this is the law of gravitation. Due to this force of gravitation, we have the law of gravitation. After 2 months search of Isaac Newton, he makes the law which is known as the law of gravitation. According to the Newton's law of universal gravitation, every object in the universe attracts every other object body with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. So this is the law of gravitation. I will explain this law in the next slide. So according to the law of gravitation, uh, we have to consider the two bodies of masses m1 and m2. See, this blue one is mass m1 and this pink one is mass m2. And we have seen that the m1 is bigger as compared to m2. The distance between the center of their masses is d as shown in figure 5.1. So first of all, we have to take the distance from the center of each mass, that is from here to the center of the other mass, which is m2. So we denote this distance with small d, and the mass in case of blue object is m1, and the mass in the pink body is m2, and there is a force of attraction between two objects, which is have to denote this force with F. This is the F force, and this is the also the F force. So two masses attract each other with a gravitation force of equal magnitude. Here the formula is written: F is equals to G m1 m2 by d square. This is basically the mathematical form of law of gravitation, and this G is the value of constant. We will discuss this formula in the next slide. According to the law of gravitation, the gravitational force of attraction F with which the two masses m1 and m2 separated by a distance d attract each other is given by. So this is basically the mathematical form of law of gravitation. There is a force of attraction between the two masses, which is m1 and m2. According to the Newton's law of motion, basically this is the product of two masses which are directly proportional to the force that is existing between these two objects. If we are discussing about product, it's mean we are taking we are doing multiplication between mass m1 and m2. And the other thing is that which the Newton state that the force of attraction is inversely proportional to the square of distance between them. We have to take the square in case of law of gravitation. Why? Because we have the two objects with each other, and why we are taking the mentioning as inversely proportional, because if we increase the distance, the force will be decrease, and if we decrease if we increase decrease the distance, the force will be increased, because they both will be have the inverse relation with each other. So in according to this law, the force is directly proportional to the product of their masses, and the force is inversely proportional to the square of distance between these two objects. If we combine these two equations, we can write it as F is directly proportional to m1 m2 by d square. So here is a proportionality this is a directly proportional sign, and we have to remove this proportional sign. So what we have to do, we have to place some proportionality constant. So in this case, g is the proportionality constant, and we call this constant as the universal constant of gravitation, and its value remains same everywhere, like the value of g. So the value of this g, which is known as a universal constant of gravitation, is 6.673 into 10 raised power minus 11 Newton meter square per kg square, right? So this is the value of a universal constant of gravitation, and you have to memorize this value of universal constant of gravitation. So as we discussed that the two masses, they have the force of attraction between them, and their distance is inversely proportional to the square of distance between them. So this law of gravitation and the Newton's third law of motion, they are also interlinked with each other. How? It is to be noted that masses m1 attracts m2 toward it with a force F, while m2 attracts m1 toward it with a force of same magnitude but in opposite direction. So why there is the same force but the magnitude but the direction is opposite? Because if we consider the force which is acting on m1 is as action force, and there will be a force on m2 that will be a reaction force. That why the force acting on m2 will be minus f, and the force acting on m1 will be a positive f, because the force acting on m1 is action force, and in the reaction, when it will attract towards the m2, it will give you a reaction force which is in opposite, same in magnitude but in opposite direction. That's why we have to place negative sign with force. The action and reaction due to the force of gravitations are equal in magnitude but opposite in direction. And you know that this is the Newton's third law of motion, which you have already learned in your unit 2. So this is consistent with Newton's third law of motion, which states to every action there is always an equal but opposite reaction. So class, this is the example 5.1. So in this example, it is given to us that the two lead sphere of each mass of 1000 kg are kept with their center 1 meter apart. Find the gravitational force with which they attract each other. So the mass of sphere is same for lead. So m1 will be equal to 1000 kg, and same m2 will also equal to 1000 kg, and the distance they are aparting from their center is 1 meter. So d will be equal to 1 meter, right? And then the law of gravitation is given by F is equals to g m1 m2 by d square. So we have to put the values in the given formula, and the value for g is always known, so you have to memorize this value, which is 6.673 into 10 raised to power minus 11 Newton meter square per kg square, and the masses m1 and m2, they are 1000 kg. So 1000 kg multiply by 1000 kg divided by d is 1 meter whole square. When we simplify these values, we get 6.673 into 10 raised to power minus 5 Newton. So this is the force which we have to find out, and and the unit for force is always Newton. So this is the gravitational force of attraction between the lead sphere which we have calculated. Then this is your homework. Read topic 5.1, the force of gravitation, on page number 107 and 108. The reason is that if you when you do reading by yourself on book, you can your concept will be clear more, right? And you also have to memorize the law of gravitation and also its mathematical form. Memorize the value of universal constant of gravitation. We have discussed the value of universal constant of gravitation, which is equals to 6.673 into 10 raised to power minus 11 Newton meter square per kg square. So class, you have to memorize this value, so it will be very easy when we do the numericals. Practice example 5.1 on your rough notebook. As we have discussed example 5.1, so you have to practice this problem in your rough notebook. You don't need to do this in your neat notebook. Okay, so this is the end of the lecture. Thank you.